This video is an overview of lesson 2.1, which is about frequency distributions. We also do a little bit of an overview of chapter 2 and chapter 3, which are all about descriptive statistics. The material in this chapter is all about visualizing data. There are 4 sections. In the first section, we'll talk about frequency distributions. In the second section, we'll talk about histograms. In 2.3, we'll talk about graphs that are enlightening and graphs that deceive, and how to avoid creating graphs that deceive, and how to avoid being deceived by often unintentionally deceiving graphs, and to create and interpret graphs that are more enlightening. And then in the last lesson, we're going to look at scatter plots and talk about correlation and regression, although we're going to talk more about that when we get to chapter 10. All this material is from Essentials of Statistics, 6th edition by Mario Triola. These slides were provided by Pearson and then modified by me to better fit our course and to better outline the learning outcomes, my objectives for you as you study statistics. Okay, so descriptive statistics. This is what chapter 2 and chapter 3 in the Triola text are about. It's all about characteristics of data. When you hear the term descriptive statistics, it's very intuitive, it's very easy to understand. These are statistics that describe sets of data. So we're gonna want to describe sets of data with these kinds of characteristics of data. The first one is center. So we might be interested in what the center of a data set is. This is a representative value that shows us where the middle of the data set is located. If you've ever heard about mean, median, and mode, those are all measures of center. We're going to talk more about those in chapter 3. We're also going to discuss variation. Variation is a measure of how much those data values vary. Are they all exactly the same? Or do they vary a little bit? Or do they vary a lot? We're going to measure that with numbers, and those numbers are called statistics if they correspond to samples. And then in this chapter, we're going to talk a lot about distribution. Distribution is the nature or shape of the spread of the data over a range of values, such as bell-shaped distributions. We're wondering, are all of the data sort of shaped like this? And I'll be a little bit more specific about what I mean by shape as we talk more about distributions. Are they all sort of concentrated at a point? Are they all spread out? Are there a lot of data values over here and a lot of data values over there? Those are all properties of the distribution of a data set. We're also interested in outliers. Those are sample values that lie far away from the rest of these sample values. A number that's very high or very low might be an outlier. And then finally, we're interested in the way data changes over time. So those are all characteristics of data. Mario Triola, the author of our textbook, gives us this mnemonic. It's CV dot for characteristics of data. And the mnemonic is computer viruses destroy or terminate. I don't really know what that means. I don't know what he means by that, but it helps you remember CV dot. C is for center, V is for variation. How much do the data vary? D is distribution, O is for outliers, and T is for time, or how data changes over time. So we're going to talk more about all of these characteristics of data in chapters 2 and 3, and we're going to start right here in lesson 2.1 with frequency distributions, which are a form of distribution. So the learning outcomes for lesson 2.1 are these. First, we're going to define essential terminology related to frequency distribution. I will tell you what a frequency distribution is, and then I'll tell you what all of these other terms related to frequency distributions are. We'll look at a frequency distribution and we will label all the corresponding parts. So we'll look at lower class limits and upper class limits. We'll look at class midpoints and all of these things for a particular distribution. Then our second learning outcome is to be able to construct frequency distributions. Now, most of the time, technology is going to construct frequency distributions for us, but it's really important that we understand how technology is actually doing that. So we're going to practice with a few frequency distributions in our homework, and we'll do one frequency distribution together in class or in the videos. In addition to constructing a frequency distribution for a particular sample, in our examples, we'll also look at relative frequency distributions and cumulative frequency distributions. And we will calculate one of these all for the same sample in the videos. And then lastly, we're going to use frequency distributions to infer properties of data. So if we have a frequency distribution and it has gaps in it, that might tell us something. Or if we have a frequency distribution and it follows a certain pattern, that might indicate that the data are normally distributed or have a normal distribution. If we look at frequency distributions of the digits themselves or the numbers themselves, that may tell us something about the original data set. And we can also use frequency distributions as a summary for particular types of data. And if you've got a summary of one type of data and a summary for similar types of data, you can put those two frequency distributions side by side and compare them. So these are our learning outcomes for lesson 2.1. If you can construct a frequency distribution, if you can use frequency distributions to think critically and infer properties of the data set, and if you can use essential terminology so that whenever we talk about something like an upper class limit or a lower class limit or a class midpoint or something like that, you know what we're talking about, then you have successfully mastered everything that you're supposed to have mastered about lesson 2.1. Now, the key concept, my one major takeaway for lesson 2.1 is this. It says, when working with large sets of data, a frequency distribution, also known as a frequency table, is often helpful in summarizing and organizing data. So you're going to have huge tables, data sets. If you go to an Excel spreadsheet and you see a couple of columns or just a single column with 100 values in it, that column with all the values in it just itself might be a little overwhelming, and you might be able to infer something about those numbers, but it would all be completely intuitive. And we'd like to take that list of 100 numbers or that list of 50 numbers or that list of so many numbers and summarize it in a smaller way in a table with a few values. That makes it a little bit easier for us to comprehend the trends. So that's what a frequency distribution will do for us. The frequency distribution is our first way to start to visualize that nature of the distribution of the data set. So whether or not that data set is sort of approximately normal, which we'll talk about a little bit later, that's a really important quality we'll be able to measure once we know about frequency distributions and can construct them and can interpret them.